First question says, estimate the fourth root of 100. So fourth root of 100 basically means 100 to the power of 1 over 4. Now we know 100 is 10 square. That's 10 square to the power of 1 over 4, which is 10 to the power of 1 over 2, which is basically square root of 10. And square root of 10, now we know that square root of 9 is 3, because 9 is a square number. And next square number is 16. Square root of 16 is 4. So square root of 10 is going to be between 3 and 4. But since 9 and 10 are closer to each other, the square root of 10 value is going to be closer to 3. So we can say that square root of 10 is somewhere between 3.1 to 3.3. So any value between 3.1 and 3.3, like, can be your estimate of square root of 10. Next question says, find the value of x. So this is from circle theorems. We can see that both x and 50 are coming out of the same chord or segment, which means they have the same value. Hence, x equals to 50 degrees. Next question says the cost of a circular table is directly proportional to the square of the radius. A circular table with a radius of 40 centimeters cost 50 pounds. What is the cost of a circular table with a radius of 60 centimeters? So we can see that the cost is directly proportional to the square of the radius. So cost is directly proportional to the square of the radius, which means C equals to K times R square. K is your constant of proportionality. If it was inversely proportional, then it would be C equals to K over R square. Because in inverse proportion, one thing is increasing, so the other is decreasing, or vice versa. But in direct, either both are increasing or both are decreasing. When the cost is 50, the radius is 40 centimeters. So that's 50 over 1600, which is basically 1 over 32. That is the value of K. Now we substitute the value of K in the equation and then again find the cost. So C equals to 1 over 32 times R square, which is 1 over 32 times 60 square, and that equals to 112.5 pounds. That's the cost of a circular table with a radius of 60 centimeters. Next question says, identify the two congruent triangles and explain your answer. So if you look at the triangles, if you look at A and B, you can see that they have the same length, 9 centimeters and 9 centimeters. Similarly, C also has the same 9 centimeters. But for B, this perpendicular length is 18, but for C, that 18 is your hypotenuse, which means B and C are not congruent to each other. Similarly, if you compare C and D are also not congruent to each other because once again, the length placement is different. But what we can do is that we can find the missing information and see whether they're congruent or not. If this is 30 and this is 90, this is obviously 60. Same for here, this would be 30 as well. Now for the length, if we find this length, we can use sine 30 equals to, sine 30 would give us this hypotenuse. So sine 30 equals to 9 over the hypotenuse. And that's 9 over sine 30. And that equals 18. So for A, this is 18. So we can see some similarity between A and C. Because if the lengths are same, that means this is also going to be 30, this is also going to be 60. Just to make sure, let's compare B and D as well. So for B, we can find the angle. If I say this is the opposite and this is the adjacent, I can use tangent tan theta, this is the value I'm trying to find, equals to 18/9. So theta is tan inverse of 2, which gives me 63.4. So 63.4 is not matching with either of these because, it's not the same. So our congruent triangles are A and C.